Welcome to video number 15, heat bed wiring. In this video we're going to cover the full process of soldering all the wires to the heat bed and wiring up the thermistor and getting it all assembled and ready to go. Okay, so don't be intimidated by this section if you're new to soldering. It's really not that bad. The RepRap tutorial jumps right past this part and assumes you already know how to do all this stuff. But I had never done any of these things, so I sourced out all the information individually. But my goal here was to give you all the reference you need to get through the wiring and the soldering. Just some tips for beginners like myself. Be very careful because the soldering iron gets very hot. So make sure it's in a safe place when you heat it up, make sure you unplug it when you're done, and make sure not to leave it anywhere where it can touch something that can melt or is very flammable. Also, for all the wiring that we do, don't leave any bare wires showing. Use electrical tape, use Kapton tape, use heat shrink, but don't let any bare wires show because it can cause shorting by touching another wire or component once we power it on. Now, what you've seen me do here is I'm using my helping hands to fix up my first wire, and so that I don't have to hold it up. And what I'm doing, it's kind of hard to see from this angle, but I'm feeding the wire, over the top of the copper, and I'm using the tip of my solder gun to melt that wire onto the copper. I believe this is called plating or coating. And we do that so that when we go to solder it to the board, it has that silver so that it can adhere to it. So what I'm doing is I'm plating or coating both sides of the wire, both wires, so that they have silver coats on them. And this side of the wires is going to go on the heat bed. So once you have got a pretty good base of silver onto the copper, we're gonna pull it out and take a look at it, make sure we have a pretty good coat on there. Now you may have a different heat bed than me, but I've got 3 different spots indicated on the board where I can solder my wires to, and I've got a 1, a 2, and a 3. Now I'm only gonna need 1 and 2 because I'm only running 12 volts instead of 24. So if you read your board, if it's like mine, then the positive side needs to go in spot 1, and that's what I'm soldering right here in the video. And then spot 2 is where we need to solder the negative wire. Now it could be switched either way. I mean, you can use whichever color you want, but you have to keep it consistent, because when we go to wire it into the ramps board later on, there's a spot for the positive wire and a spot for the negative wire, and you don't want to get those in the wrong position. So for now, white is my positive and black is my negative. And it should be pretty standard across the board for all of these heat beds. They should be laid out the same way. So just make sure that you get them in the right spot. And as you can see, I'm just taking the tip of my solder gun and I'm trying to melt that blob of silver to where it's going to bind both with the board and with the copper wires and make a clear, solid connection. Now, this is the first time you're going to see me use the multimeter, and what I'm using it for, and what I primarily use it for, is to check for continuity between my soldering. So just to make sure I have a good connection, I set the multimeter to test for continuity, and as I'm touching the different pieces that I soldered, it should be making a beeping noise. Now you're not going to hear that in this video, but there is beeping showing that I did solder them correctly, as in these two wires that are only connected through the board are showing that I do have a good connection. And once you know that you have continuity and a solid connection, it is important to secure it with some Kapton tape to make sure that any other kind of force isn't going to rip it off or to damage your solder joints. So this is to make sure that you keep it secure. So moving on to the next step, we got some more soldering to do. This time we're going to solder up our thermistor, and this is going to be the piece that acts like a thermometer, and it's going to measure the temperature from the heat bed and respond back to our software so that we can accurately adjust the temperature to the heat bed depending on what we need it for. So you're going to see me go through the same process here, where I'm going to mount up the wires, and you're going to see me once again melting a coat of silver. My hand's a little bit in the way, but I'm just real lightly feeding the silver onto the copper and then melting it on there until it binds with it. It's always a good idea before you move on to your next wire and connect the two to go ahead and put your heat shrink onto the wire, because once you solder them together you're not going to be able to slide it on there anymore. So it's good to go ahead and get it slid into place where you're going to need it. So the leg of the thermistor for this is going to be pretty small, and it's kind of hard to get a good bite on it, but just be real careful whenever you're melting it to make sure that you don't actually touch too much of the protection on the thermistor and melt it, or even bring it too close to your heat shrink, because then you can seize up your heat shrink. So this might be a little bit trickier to solder, but follow the same steps. Once you have a good coat of silver on there, just make sure you hold it just long enough for it to bind. But it's real important once you get that connection that you really want to slide your heat shrink over and light it up and melt it in place to make sure and secure your solder joint before it has a chance to break off. Once we have a thermistor with 2 wires running out of it, we're going to need a way to connect the thermistor to the board. So we already have the wires that are long enough to probably reach the board, but we need a way to connect to the pins. So what I'm doing is I'm soldering on a wire to each of the 2 wires that has a connector on the end that will fit onto the pins on the ramps board. So once again, I'm going to have to extend these wires so that they have some kind of a connector on it. And I'm following the same steps that I have in the last few scenarios. So once you have this connection, go ahead and get your heat shrink on there. And you'll notice my heat shrink was actually a little too big, and it didn't seize up too well. It still ended up being okay, but you know, I'm also going to use electric tape and anything else I can to make sure that it stays secure. But what's important is that you have good solder joints and you have something protecting them, and that there's no wire showing, because you don't want these things touching when it's powered on. It'll start to short out. So at this point right now, we have all the wires we need for the heat bed. Final step here is, as you can see in the pictures, we already have all the wires we need, but we need to get the thermistor taped into place so that we can get the most accurate temperature reading. And for that, we need to get it right in the center, and we need to make sure that the head of the thermistor is touching, you know, right there on the board, right near the center. That way we can get an accurate reading whenever we have it talking to the board later on. And this is where Kapton tape really comes into use, because it's a high heat tape, and whenever we're constantly heating up the heat bed, it's not going to damage it and lose its adhesion. So I'm going to go and put tape all the way down the wire to make sure that there's no place where it can snag, or you know, no place where it can begin to come up. I want it to be nice and secure so that there's no pressure really on the thermistor, or even the original two wires we soldered and taped up.